Number 2 is 2/7, and number 3 is 45A. If you got those both right, I suppose you could move on, or you could stay tuned for an explanation. In a class of 20 boys and 15 girls, 10 boys and 8 girls speak more than one language. If a representative for student council is to be chosen at random from the class, what is the probability that the representative will be a boy who speaks more than one language? The actual most straightforward, easiest way to think about this is just think about the 35 possible outcomes, 35 students from which you can choose a class representative randomly, and then think about the favorable outcomes. How many boys speak more than one language? 10. So there's a 10, if you're trying to pick a boy that speaks more than one language, there are only 10 favorable outcomes. The greatest common factor of 10 and 35 is 5. So you simplify to 2/7. Another way to think about this is the probability of randomly selecting a boy multiplied by the probability that that boy speaks, or yeah, I'm trying to think of the best notation here. Once you've got a boy, once you've randomly picked a boy, what's the probability he speaks more than one language? We've already accounted for the fact that it's a boy. The probability of picking a boy is 20/35. You multiply that by the probability that a boy, a randomly selected boy, speaks more than one language. Well, the 10 of the 20 boys speak more than one language. So you're multiplying by 10/20ths, or 1/2. I'm not even going to show 1/2 because I'm going to cancel the 20/20ths. Recognize that that's one whole. And then I get 10/35, which is what we had before. So there's just a different way of thinking about that. Number 3, 10 members registered as a team for a math contest. If one handshake is made, this is a pre-coronavirus question. I never thought about this until just now. These shaking hands questions are very common combinatorics questions. I wonder if it'll take decades because problems are used over and over again, but they may eventually disappear. We don't shake hands anymore. We bow respectfully. 10 members registered as a team for a math contest. If one handshake is made between every 2 members, which of the following could be the total number of handshakes in the team? Let's see. You've got 10 people. If they're shaking hands, you're selecting 2 people from those 10 people. So it's kind of another way of saying how many ways can 2 people shake hands if you've got 10 people all shaking hands with each other. Then the other question is, does the order matter? Well, if person A shakes hands with person B, isn't that the same as person B shaking hands with person A? Since the order does not matter, it's a combination of 10 people selected 2 at a time. That'll give us all the possible combinations of handshakes. So it's 10 factorial over 10 minus 2 factorial, 2 factorial, or 10 times 9 times 8 factorial. I just expanded the numerator down here, over 8 factorial times 2 times 1. The 8 factorials cancel, and the 2 and the 10 factor 2 out of each of those, and you get 5 times 9 is 45. The reason I paused so long a minute ago is I was thinking about showing a tree diagram, and I think I will briefly, but I'll only show part of it. I'm not going to show all 10 people, but Annette, Bill, Craig, Donna, our friends, our friend Egbert, our friend Fred, and so on and so on. But A could shake hands with B, with C, with D, with E, not with themselves, but so there are 10 choices for the first person who's shaking hands. Bill could shake hands with Annette. Bill's not going to shake hands with Bill. That would be odd. That wouldn't really. But Bill could shake hands with Craig or Donna, blah, 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 blah. In other words, once you pick a person, there are 10 people to choose from. Who they shake hands with that would be 9 choices, because they're not going to shake hands with themselves. And then we would divide that by 2, because you're going to have pairs like this: Annette, Bill, Bill, Annette. Well, isn't that what we ended up with? 10 times 9 divided by 2 once the 8 factorial is canceled. That's just showing you how that sample space sort of reveals the combinations formula.